All right, chemistry, this is your video lecture for chapter 6, sections 1 and 2. This is part 3 of your 3-part video lecture. So we're going to finish up section 2 here. And in order to do that, we need to cover the last 2 objectives for this section. That's write Lewis structures to illustrate ionic and covalent bonds. That's going to be the one that we really focus on. And we're also going to try to write some Lewis structures for polyatomic ions and molecules with multiple bonds. Okay, emphasis on that multiple bonds part. All right, so let's get to where we left off last time. And I'll point out, even before we get there, what you're looking at here, these are Lewis structures right here. You guys have seen these before. I've even drawn these on the board. But now we're going to actually introduce a set of instructions on how to properly create those. First step is something called Electron-Dot Notation. In Electron-Dot Notation, an electron configuration it is an electron configuration notation in which only the valence electrons of an atom of a particular element are shown, and they're indicated by dots placed around that element's symbol. And so here's a periodic table. These are the main group elements. Okay, so these are the elements that we're going to be working with here. Main group 1, main group 2, main group 3, main group 4, main group 5, main group 6, main group 7, main group 8. And you can see that each of these elements, we have the symbol, but it's also indicated the number of valence electrons that each of these elements have by the number of dots that circle the element. Right? And this matches the main group that we see here, the only exception being helium, right? Because it's in main group 8 over here because it's a noble gas. However, it only has 2 valence electrons because with n equals 1, the first period, you can only put 2 electrons into that energy shell. But everything else, this is a reference table for you to use. If you need to draw sulfur in electron dot notation, we have it for you right here. But I do want to point out that each group, because you have the same number of valence electrons in a group, you're going to have the exact same distribution of valence electrons around that symbol. Okay, so you can use this table as a reference. However, I would prefer if you understood the connections between the group number, or should I say the main group number, and the number of valence electrons. So moving forward, let's see if we can try one. Write the electron dot notation for each of the following elements. Now I have 6 elements here. Go ahead and press pause, and we'll see what we can do here. All right, see how we did. Hydrogen, being in main group 1, has 1 valence electron. So we're going to represent the electron dot notation for hydrogen as such. Argon, it's a noble gas, so it's going to have 8 valence electrons. We're going to draw 8 dots around argon. Go over to phosphorus. Phosphorus is main group 5, in the same group as nitrogen. And we're going to have 5 dots. Chlorine, main group 7, 7 dots. Calcium, main group 2, 2 dots. Aluminum, main group 3, 3 dots. And notice that some of these dots are paired up and some of them aren't. Remember when we were going over electron configuration, there are 3 rules that govern how you write electron configuration. And one of those rules states that before you go and double up an electron within a suborbital, that each of those suborbitals must be singly occupied by electrons of the same spin. That's what's happening here. We can fill 1, 2, 3 electrons, valence electrons on aluminum. If we were to get to carbon, we'd have 4, but we would spread all 4 of those valence electrons out around the atom before we went back and doubled anything up like we have here on phosphorus. Now, for drawing Lewis structures, we're going to take this same idea from the electron dot notation where valence electrons are the only electrons that are indicated. Why? Well, they're the only ones that are involved in bonding. And we're going to represent those as dots. But we are going to represent entire molecules. We're going to represent compounds here. Now, on this slide, I have the steps to follow in order of how to draw a Lewis structure. And you will definitely want to reference this throughout the rest of this section. First, determine the type and number of atoms in the molecule. Number 1, figure out what you have and how many of them you have. Next, write the electron dot notation for each type of atom in that molecule, right? We just identified what type of atoms we have. Now write down the electron dot notation for each of those. 3, determine the total number of valence electrons in the atoms to be counted, right? We're going to make sure, look at the main group number that element is in, make sure we're aware of how many valence electrons there should be. 4, arrange the atoms to form a skeleton structure for the molecule. Now, there are some sub-rules here, like, skeleton, how am I supposed to arrange these elements? Keep this in mind. If carbon is present, it is the central atom. Okay? It's organic chemistry. If carbon is present, it is the central atom. That is like a forever rule. So if carbon is there, it is automatically the central atom no matter what. Everything else is going to go around carbon. Otherwise, if carbon isn't there, simply find the least electronegative atom and make that the central atom. The only exception being hydrogen. Okay, even if hydrogen is the least electronegative, it's never central, so never put it in the middle. Okay, it can only form one bond. But remember, in this very note packet, you have a periodic table that is chock full of electronegativity values, so you don't have to remember these things. It'd be nice if you remember the trend with regard to electronegativity, but since you have access to that table, use it. Don't guess. Check these values to make sure you understand which atom is the least electronegative. Then start connecting. Once you have that skeleton structure, start connecting the atoms using electron pair bonds. Number 5, add unshared pairs of electrons so that each hydrogen atom shares a pair of electrons and each other nonmetal is surrounded by 8 electrons. And lastly, this is more of a check thing. Count the electrons in the structure to be sure that the number of valence electrons used equals the number available. This goes back to number 3. Okay, remember the reason we counted the total number of valence electrons around all the atoms that we can possibly use. When you're done, go back and make sure that you have that exact same number of electrons, because by bonding, we don't get to synthesize or bring in new electrons. We're simply sharing and transferring electrons from atoms that we've already represented. So we need to make sure that those numbers are the same. Now, we're going to have a check for understanding. You guys are going to try to practice this. Use this list and follow it. Okay? Follow this list actively. So, draw the Lewis structure for bromomethane. Now, you guys don't know naming nomenclature yet. But bromomethane is CH3Br. Now, again, refer to the 6 steps. Don't try to do this off the top of your head. You can't do it. You're going to get stuck. You're going to sit there and do nothing. Follow the steps. Follow the steps. Please press pause now. All right, one of the first things we need to do is identify what elements are present. Now, we have bromine, we have hydrogen, and we have carbon. I have 1 carbon, 3 hydrogens, and 1 bromine. Okay, so now I've identified how many of each atom type I have. Next, I'm going to draw the electron dot notation for each of those elements, which is as follows. Now, looking at this setup, I can tell just by looking that carbon can form 4 bonds. Carbon can form 4 bonds, which is handy because there are 4 other atoms in bromomethane. Looking at that chemical formula, I can see that there are 3 hydrogens and 1 bromine. Well, that's 4 atoms. Well, that, my friends, is why carbon is the central atom. Okay? Remember, if carbon is present, it's always the central atom. So I'm going to stick carbon in the middle. I'm going to share electrons from bromine and carbon, right? The one single electron, the unpaired electron from bromine, I'm going to pair it with 1 of these from carbon. And then I have 3 of these hydrogens, each with 1 electron that's available for bonding. And I'm going to stick a hydrogen on each of these other 3 carbon unpaired electrons. And so when I'm done, it's actually going to look like this. I have carbon, it's central. Okay, central just it means it's in the middle. And I surrounded 3 hydrogens around the carbon, and then I have my 1 bromine. Now at the end, I go 1, 2, 3, 4, 5, 6, 7 electrons on bromine, 1, 2, 3, 4 electrons on carbon, and then 1 on each hydrogen. So that's going to make 7 plus 4, that's 11, plus 3, that's 14. I'm going to count the number of electrons in my structure right here. Hopefully this should be the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. I counted 14 earlier. I have 14 now. And so I have the exact same number of valence electrons that I started with in my final structure, and that is a great way to double check that you are in fact correct. Right? Check your work. Don't simply write something down and hope for the best. Take every step available to you to make sure that you got this correct. All right, guys, and that's going to bring us to the end of Section 2, and that concludes our video lecture series on Chapter 6, Sections 1 and 2. I will see you next period.